And today, our agenda, we're going to be starting out just reading and writing data, creating variables. Can everyone see my PowerPoint?
Yep, looks great.
Okay.
Yep.
Want to make sure. So then we'll talk about combining data frames, group by processing, summarizing data, pivoting data, working with duplicate data, and tables and listings. So all the programs and everything are in the directories of the RStudio project that we have. If we don't make it through everything, you'll still have those that you can look at your leisure. Once you get into an RStudio Cloud project, you should see this directory structure. Cloud Project Workshop. Even though the C in Cloud looks like it's capitalized in RStudio Cloud, when you see it, it's really, all right, I see some of you have already clicked the new project. So again, you've got to be in this space. If you're in your workspace, then you're not going to see all of our packages and files we have preloaded. You have to click on the R in Pharma space and then click New Project. And you choose the RStudio project. And it does take, seems like a long time to start up, but it's not that long. All right, so this is an RStudio desktop environment that's very similar. If you have it installed on your laptop, it's pretty similar. I'm not sure why this stuff is still in here, but with a lot of these windows, there's a little broom. You just clear it out. And same with these data frames. Let's start clean. And let's take just a little tour. Like I said, in the file space of RStudio, there's a Files tab. And in that, you'll see the file structure that I showed you in the PowerPoint. There's Cloud Project, Workshop. There's Workshop Code and Workshop Data. So what we're going to do is we're going to go through some code. Then you'll do a brief exercise. Then we'll discuss the solution. So that'll be a common theme throughout. I've got 10 programs queued up here. We may make it through all of them. We may finish early. It all depends on what's going on. So we're going to take a break probably every 45 to 50 minutes, just so we can stretch our legs, maybe get some coffee, glance at email. And so we'll I'll announce that when we're going to take a break. All right, hopefully you are all in by now.
Do you mind to show one more time how you get there?
This
window here, the R window, how did you open that?
Okay, so when you first go in, there's no script file open. So you can do new file R script. Now I've got two open.
Yeah, I don't even see this option there. So where should I go to and look into that? Yeah, even not even the RStudio screen.
Okay.
Yeah. You know what?
I don't see it either. I don't see the Intro to Clinical R Processes tab.
Okay. You might have to click on your ID and go down to Organizations R and Pharma, maybe.
Oh.
Yeah, I'm gonna put another link in the chat box. It's the same link that we've been sending, and you want to make sure once you're inside of our Studio Cloud that you click on this link that we just put in the Zoom chat. It will take you into the organization for RN Pharma, which will also put you directly in the classroom. And then once you're in that, once you clicked on that link there, you'll be able to click on New Project and you'll select our Studio project. And so, yep, so Brian's showing you right now. So once you go inside, click that link, it will take you to a page that looks a little bit like this, but it will be empty for you. And then you'll just launch a new RStudio project. And if anyone has any questions on this, or if you're having trouble getting stuck, feel free to message me in the Zoom chat. But once you launch the RStudio project, it will take you into the environment that Brian was showing you, where he's got the examples and the things loaded. Yep. All right. And Brian, just while we're getting things set up, you might exit or click an X on the left side, and also the message on the type, it just make it a little bit bigger for you for the recording. Right, we're up in the left where it says RStudio Cloud, there's a little X there. You can help give you about 20% more space. Yeah, there you go.
Oh yeah. Oh,
yeah,
good.
and then at the top, you can exit off of the yeah, that one too. Probably know that at this point. Yeah, and then yeah, and so this just makes it a little bit bigger. And if anyone has trouble, let me know. But yeah, the key thing is making sure that you got into the right the right classroom space.
All right. So I guess the two people that were having problems are you all set now?
Yeah, I'm good. Thank you.
Okay. All right, so let's get started. Again, this interface, if you're not familiar with it, we've got a script area over here, a console, it's almost like a little log area. It'll give you messages, and if you don't do something quite right, it'll give you a warning or error message. Up here is an environment. Pretty much we're going to stick in the environment tab. It shows you your data sets and variables you have and vectors. And then down here, kind of the important tab is our file tab. So again, it's cloud project into our workshop folder. And this is a lowercase c here. See how it shows /cloud with a lowercase c. You could be tricked into thinking it's uppercase. All right, going into, let's get into some code here. So we're going to dive right into reading and writing files. Okay, so we're going to, if you're not completely familiar with the interface or R coding, comments start with a hashtag or pound sign. So you can see these are green. And if it ends with more than 3 dashes, it makes what's called a section. So you can see in your program the different sections. That's kind of nice if I want to jump down to a different section or up. It's kind of a nice organizational feature. Okay, and when you start up RStudio, you've probably got, chances are you have all the packages you need installed, but they don't start out as being loaded. So for example, with this one, I kind of know what packages I'm going to need based on what I'm going to do. So I try to put these up at the top, and the library function will load the package. So as long as you have it installed, the library function will load it. And I want to point out this tab over here with packages. This lists all the packages you have installed, what version they are. And if there's a little check mark, it means it's already loaded. So the base R, it's going to load automatically. You kind of need that for everything. Okay. Now to run code, you just need your cursor on a line, and I can hit run, and it'll run that line. It can be at the beginning or the end. You can also highlight a section and hit run, and it'll run everything that's highlighted. So sometimes you might mean just to have your cursor on a line, but you really accidentally highlighted one letter, and might be confusing because you say, what's H? Oh yeah, I've got to highlight. I do that sometimes. Okay, so we got the packages loaded. Another important thing is to realize what your working directory is. So here's a couple of handy functions. Get WD tells me what my working directory is. So I can see right now it's cloud project, workshop data, which is what I want. If it wasn't that, I could run this line. Set WD, set working directory. And then I can check it after that, make sure it's what I want. So that means that's this directory. When I read or write files, by default, it's going to go into workshop data. Then I can, just as a relative path, work off of workshop data. And you'll see what I mean by that coming up. All right, first we're going to talk about CSV files. We're going to talk about 4 or 5 different types of files you might want to read or write into R. And CSV files, of course, they don't have any attributes on the variables. It's just text. So it's always handy to see, well, how is R going to interpret this if I read in the CSV file without like setting a bunch of specific options. So here's a function called spec_CSV. And if I run this, okay, so I put the file crf dm.csv, and that is down here, dm.csv. So since my working directory was already at workshop data, all I have to put is crf/dm.csv, and it's just a relative path to my working directory. I could also put the whole path, but don't need to do that. So this kind of tells me, it gives me an idea what columns are in this CSV and what type is going to get assigned to them automatically. So this is kind of handy to be able to do that. Now, if I want to actually read in the CSV, there's a function called read_CSV. Now, just like any programming language, there's multiple ways to do the same thing. And there are other functions that you could use to read in the CSV. In this case, I'm using the read_CSV. And if I put my cursor on that function and push F1, it's pretty handy because the help comes up over here. So you can see usage on this. I can see what package it's from. It's from the reader package, read_r package. So if I'm not really familiar with a function, I do that, push the F1 key, and kind of read up on the function. In this case, I'm just going to define a couple of parameters. I'm going to point at the file, and I'm going to tell it which columns I want out of here. So I knew these columns are in here because I did the spec underscore CSV and saw them here. So I can put my cursor anywhere on here and read that out. Then I can use the SPEC function just to see what my data frame looks like. And you can see it's got all the variables here, but I didn't read all of them in. So anyone I didn't read in, it just shows col skipped here. Another way to look at this is to, there's a function called glimpse. And I could also look at the data frame that way. And that might be in another library or another. That's what I get for going off course here. Must be somewhere in the tidyverse. Looks like it's in dplyr and Tibble. So I just needed to read in the tidyverse, load the tidyverse package. And I can see my columns. And I can see the first few values of each one. Another way I can look at my data frame is up here in the environment tab. It shows the data frame I just built. 87 observations, 4 variables. And I've got, I can click this blue, see all the variables in here, same as a glimpse. I can also click on it and it opens it up. I can see it. That's pretty nice. There's even a little search here. I can put in 49. It looks for the 49. Must be it's only on this row. So these 3 have 66 in it somewhere. So this is a nice little way of getting to know your data. All right. Okay, so next let's look at an XLSX file. Let's take this data frame I just made and write it out to an XLSX file. So this takes 2 parameters. The data frame I want to send in and the Excel spreadsheet I want to make. So I can run this, and I know my working directory is workshop_data. So I can see here this made this XLSX spreadsheet. And if I want to read that back in, I can use a function called read_Excel. Just point at the spreadsheet, and it comes back in. All right, so as you can see, it's just function calls. You just need to know the right function to call. How about if we want to read in a SAS data set? So again, there's a function read_SAS from the Haven package. I just point at that file and I get it in here. Okay, So mostly what we're going to be doing for the rest of the course is just working with data frames. That's the R object. That is the tabular data structure, like data sets or tables and other software packages. And the ones we're going to be using have a .rds extension. And there's, again, a few different functions you can use to read these in, but the read, capital R, capital D, capital S. Again, the functions and variables and vectors and data frames and directories are all case sensitive in this environment. So we just do name the data frame we want to make, put the assignment statement here, and call the function. There, we brought in this from sdtm dm.rds. So we read in this file and it loaded it into a data frame in memory up here in the environment so we can use it. And if we have a data frame in our environment, it's essentially sitting up in memory, we can write it out to disk, which would be down here in the files area. So we can take this data we just read in, that we put in this data frame, and write it out to dm_from_rds.rds. So if I run that, you can see it sitting right here. I didn't specify any further directories, so it goes to the working directory, which is workshop_data. Okay. All right, so that concludes this first class code. So the way this works is now you should go into the exercises and open up the 01 reading writing files exercise.r. You just click on it, it'll open up right here. And in here, it'll ask you to fill in things to finish out. So the request is in the comments, and then you just need to finish the code to get the output that's requested. So it's very similar to what we went over. It's just now you're on the spot to fill in these, finish these function calls.
Can you explain the very last one you did, which is read RDS, one more time, please?
Sure. Okay, so right now we have data frames, which is the proprietary tabular data structure in R. And we've got some sitting in memory because we read them in. And we have some on disk down here in these directories. This is on the file system. These are in memory. So the save RDS takes two arguments. The data that you want to write out or save to disk. And then here is where you want it to go on disk. And this says dm_from_rds.rds. So that went out here to our working directory. And it got written right here. Did that help?
Yeah, so basically with this read RDS, you're just reading in the file, putting it into dm_from_rds, and then saving it.
Yes, this is the read RDS reads it from disk and puts it up here in memory.
Yeah,
And then the save RDS takes it from your session and puts it down on, writes it to disk.
gotcha. Thank you.
So can I ask a question?
Sure.
So how do I know these like a read RDS is from package haven or from like read or write Excel?
Okay.
Yeah.
So if I put my cursor on it and hit F1, it will show me the help for it, and it'll tell me which package it's from.
Oh, okay, great. Very helpful. Thank you.
You can also run the class statement on a data frame. That one also can help you. So if you just put class down there, Brian, in the console. Yep, right there. And then type CLASS. Yep, perfect. And then put inside of that the name of the data frame, like in the parentheses.
Okay.
Yeah. And then,
She was talking about how to tell what package a function is from.
oh, I thought I heard her say where the data set came from. Oh, okay. Got it. Yep. Well, if you do that, it will tell you if it's a Tibble or if it's a data frame. Data frames typically come from non-tidyverse packages, and Tibbles, which is what we just listed there, comes from the tidyverse. If that's of interest, hopefully it helps, but I think I misheard it.
Oh
Okay.
yeah, but I think I also need to learn about these class. Yeah, that's also
Yeah, the class basically just tells you what class does the object belong to. Does it belong as a data frame or as a Tibble? A Tibble is a special name for a data frame that's created from the tidyverse. And so if you use Haven or readr or readxl, any of those packages that are part of the tidyverse, they'll create by default Tibbles. It's kind of a strange thing, but nothing to worry about too much. They're all data frames basically.
But the
Right.
one that you load in the memory, those 4. So
Yeah.
what?
So these are data frames sitting up in memory, and
Right.
like Phil said, some of them could be Tibbles. I just use the word data frame loosely. But if in the environment tab, you can also switch to what's called a grid view. And
Okay.
this will, a lot of these functions I was using was probably from like readr or dplyr. And they create, you can see they create Tibbles.
So is there like inherent?
Or I'm
difference?
sorry. It's TBL_DF is a data frame.
Yeah. Yeah. And, I wouldn't worry too much about the Tibbles. I think you got it right. Basically, in R, there's data frames, and typically you bring in a raw flat file or a SAS data set or Excel data set or a CSV. You use the correct corresponding R package to basically convert that from that file type over to a data frame. And then once you've got that data frame listed, it's in the memory of the server, and you can see it right there where he's showing. The only little nuance that I was pointing out is that if you import a data set and convert it to a data frame using a tidyverse package, it will convert it over to a Tibble. And a Tibble is just a special name for a data frame in the tidyverse. And it's kind of nice for beginners to know that, just because it can trip you up a little bit. But all of those data sets that Brian are showing there are Tibbles. And in that view, actually, I've never seen that. It's a really cool view. All of those are Tibble DFs, which are basically Tibbles right there. Yeah. And so, Brian, if you do down in the console, if you do like class and type in tooth growth and see what pops up, you'll take a look. There you go. And then put tooth growth. Yeah, perfect. Hit enter there on that. Right there. If you just hit enter, it should, there you go. And see how that says, hey, tooth growth is a data set built into R, but it's just a data frame.
Okay.
Yeah, so sometimes you'll see, if you list out a data set, sometimes you'll see it's a data frame, sometimes you'll see it's a Tibble, but they're all data sets. And so that's why Brian was very correct. So don't get too tripped up by it, but it's a good thing to know about.
All right, thank you.
Yeah.
I have a question about saving. So when I'm writing a file to this on my working directory, is it the same working directory as yours, or do we just have like a clone of that file structure when we open up the project?
You clone it, you have your own environment. So what you create is not going to pop up here. And what I create is not going to pop up in your environment.
So my environment's just a copy of everything that was in your environment when I started, right? And then
Correct.
as I save things to that environment, they're going to save just to my environment.
Correct.
Gotcha. Okay, thank you.
All right. Hopefully everyone's having an okay time filling in the blanks here for this. We'll give everyone a couple more minutes, then kind of glance over the solution and start off on the next program.
Hey, Brian, while you're doing this, I'll just mention real quick. I got a couple of questions from people that have taken some of the other workshops, and in those workshops, there's an existing project that's an assignment. In Brian's workshop today, we're using a base project, and so when you join the classroom, you won't see the project listed. So what you have to do is just click New Project, and then when you do that, it will launch the project for you. And all of the examples will be inside of that project, and it's inheriting that from Brian's base project. I've got 4 or 5 people that were trying to figure that out. I think it's just because they had come to the other workshops that had used kind of a different way to get to the same place. So just wanted to mention that for those of you that are on the workshop today.
Yeah, I see the 3 data folders, but I don't see the sample program. Because the other workshop have the program like question 1, solution 1, they're all listed in the share folder, but I don't see it.
Are
Yeah,
you
you
in
just gotta go-
workshop code?
Yeah, you just got to go back 1 level at the.
Oh, up 1 level. Okay.
Yep, up 1 level. Yep. Once you go up 1 level, you see workshop code and then workshop data, and you
Okay.
should be good to go from there. Yep, you just kind of got to navigate the folder structure, doing exactly what Brian's showing on the screen.
Yeah, we'll all be pros with this folder structure before we're done here.
Yeah, right. Actually, it's a really important thing for beginners because, especially if you're coming from other languages, you set the working directory or you have your correct paths. In RStudio, like if you want to make where Brian is operating now as the working directory, you can use a function to say, hey, operate from here, or you can also click on the more button to the right-hand side down over in the files pane, Brian. That will also set the directory for you. Yeah, right there, exactly. And so as you work with your data and your programs, you oftentimes have to move around different directories. And so you kind of have to, you kind of always have to know where are you at and where does R think you're at and where do you think you're at? And sometimes those don't match up. So having those functions that Brian showed at the beginning are really helpful for you navigating things.
Yeah, and if you're like writing a program that's going to be part of a production process, it's probably going to be some kind of environment variable, or you're going to have this run with all the people that are working together. Say it's on one study, you're all going to want to have the same definition for working directory. Okay, so let's just go into the solution here, and if you get done, you can go ahead and go into the solution and look at it. If you're really struggling with something, you can just open up the solution and come in and look at it. So this one just had fill in the working directory. So this is right here. Another way you can do it is you can say choose directory. And let's say I choose the one we want. It puts that statement for you right in the console. And you can copy it right into your program. Okay. Down here, I wanted to look at the attributes for this file and just had to put in the file name here. That's the relative path because it's going off the working directory. And the rest of these are similar. You're either putting in the name of a file or the name of a data frame. All right, so this is a good one just to get warmed up with. Hopefully no one had too much trouble with it. So I'm going to go ahead and get started on the second one. So I'm just going to close these. But again, they're yours. You can download them and stuff. I can show you how to do that at the end.
I'm sorry, quick question. Does it matter whether it's double quotes or single quotes?
It doesn't matter whether you use double quotes or single quotes. Of course, the beginning and end has to match. They have to be the same type of quote, but you can use either one, double or single. All right, so second, we're going to look at a way. So you got your data read in, maybe you want to create some variables. So again, you can spend like a whole day just talking about creating variables if you want to go in down to the details and the weeds. But what I want to do in here is kind of get you started with it. So we talk through some example code, then you do an exercise, and then you can look at the solution. Of course, all these topics here, it'd be probably a multi-day course if we covered it in depth. So I'm just trying to give you a taste of each of these so that you have some code maybe you can apply in your work or use it to leapfrog your learning. Okay, so we're going to start a new program. It's kind of nice. Maybe I want to clean up these data frames so they're not cluttering up my environment. Same with the console. Clear that out. Notice that little broom. All right, so let's just start over. Another way you can even start over more fresh is to restart R. Okay, now you're starting out kind of a little bit more of a fresh environment. And here I'm going to load a library called Tidyverse. The Tidyverse, you can think of it as a meta package. It's a package that has other packages bundled in with it. Some packages you use, it's just one package, but Tidyverse is a package that contains multiple packages. So you'll see you get some information down here when you load Tidyverse. It's telling you what sub packages or the packages inside of Tidyverse that it's loading automatically. And then it talks about conflicts. And these are function conflicts. So a little bit about that. So there's a filter function in more than one package. So there's a stats package that gets loaded by default. And I just loaded Tidyverse, which has dplyr in it. So this is important to pay attention to because this is saying that the dplyr filter is the one that's going to be used if I just call the filter function. If I want to be very specific and avoid the risk of calling the wrong function, I can put package name, : and then the function. Same with this lag function. Let's say I want to use the lag function from the stats package. but I loaded tidyverse, and the dplyr lag is going to be the default one if I call lag. So if I really want to use the lag function from the stats package, I have to specify it like this: stats : lag. Okay.
But
So
are they the same function though? I mean, they
It's-
perform the same thing.
there are two different functions. They're in two different packages, but called the same thing.
Okay.
Because think about how our packages are developed. Everyone that develops a new package, they don't go and make sure all the other packages don't have the same function name. So if I create a package called Brian's package, and I have a function called hatchet, and you create a package called my package, and that has a function called hatchet, we can both develop those packages, load them up to CRAN, and CRAN's not going to say, you can't have this package up here because it has a function that has the same name as a function in another package. Just the two packages coexist with the identical function names. So this is important to understand because it can be very confusing when the function's not doing what you want it to.
Okay.
Okay. So got off on a little tangent there.
So if you call it, if you call that function without the, the package name : if you just call if you just called filter, I'm sorry, which one does it default to? Will it default to the deployer, the dplyr or dplyr or stats?
It defaults to dplyr
Okay.
if the dplyr package is loaded.
Gotcha. Okay.
If dplyr package is not loaded, it will default to the stat.
Gotcha. Thank you.
You're welcome. Okay. So the last thing we looked at was just reading in data. Once you read it in, you may want to enhance it with some of your own variables. So you can see here, this is what we were doing in the last program, reading in data. Then I have this percent greater than percent. And that's called a pipe. And that's from the McGritter package in the tidyverse. So what the pipe does is it passes the information from the previous operation into the next operation. And then I have another pipe that passes the information into the next operation here. So these are all separate operations strung together. Whatever the result of this operation is, this pipe passes it in to the next function call. Okay, so some common things that you'll do: you read in data, you select the variables you want, and you filter it, and you may create some variables. So this is an example of just that. So I can highlight this up to the pipe and run it. And I restarted my R session. So I've got to reset my working directory. So there's a few ways to do that. I can get to my working directory that I want. And set it there. And you can see it puts that command in here. like we had in the program. So if I want to be sure this program runs, I can just have this up here. And now it should be able to find that data frame. All right. If I want to run the first two operations, I can just highlight it like this. And this is a good way to debug. If you've got a bunch of stuff connected with pipes, a good way to kind of debug it is start from the top and then keep adding another operation and see if you're getting what you want to get. Okay, so now I ran this, it's selecting these 4 variables. Now you can see I've got 4 variables. Okay. Now let's run the first 3 operations. Read in the data, select the variables I want, and then filter it. If I run this, notice I've only got 21 observations now and 4 variables. Now, if you're new to R, you might wonder, why does he have 2 equal signs here? Because that's how you compare 2 things. This is the operator for saying if when arm is equal to arm B, those are the only records I want. I use 2 equal signs. If I'm assigning something, setting something equal to something else, I use 1 equal sign. So this is for comparing, and this is for setting it equal to something. So in here, you can see it's only arm B in here. And now we finally get to creating new variables. So one good way to create new variables is with the mutate function. It's like my favorite way of creating variables. Okay, so in this data, I've got a variable called sex. It's either capital M or capital F. Let's say I want to change that to 1 or a 2. Okay, so I can use a case when. So when sex is equal to capital M, so I'm comparing, that's 2 equal signs. I want it to be a 1. And the syntax is tilde 1. So this is like kind of an if then else. If this, then 1, separated by a comma. Else if this, a 2. Else if anything else, I set it to an NA, which is it's like a missing in R.
So is
And-
case 1 a function from base R or from mutate?
Right, so mutate is from dplyr,
Uh-huh.
and case when is also from dplyr.
Oh, okay. Okay.
Like if I'm programming, I like using the mutate function. Now, R is a big language and there's a lot of other ways to do stuff like this. But this is one way to do it. There's also a function called if else.
Okay.
But I prefer the case when. It might be maybe a little more typing sometimes, but I think it's easier to read.
I also have a question about the pipe that, you read in the data set and then you select for variables. So this is equivalent of a where statement instead of putting the where condition in the parenthesis when reading the data set. So is there any way to only read full variable of the data set into memory? Is that
Right.
No?
I would
So,
think of it more as an and then.
so it's,
Yeah.
so this is, so it sounds like you're kind of talking in SAS terms.
Yes, I'm trying to find our equivalent for the
Okay.
SAS option of either
So,
the where
yes.
statement or the where condition.
Yeah, so this is like reading everything,
Right.
like you're setting it in. This is like you're using a keep option, keep these variables. And then this is like using an if statement or where statement.
So when you see that pipe, typically what I tell people to think in their head is the and then. So you can say, hey, I'm going to create a new data set called new DM, and it's going to be equal to the DM RDS data set. And then when we hit our first pipe, it's going to be, and then select the columns we want, and then filter it on the filter we're specifying. And then let's mutate and create new columns.
Right.
And so that
For small data set, this is fine, but for a large data set, I want to read in only the variables I need. I don't want to read everything in and then select.
Right. There's definitely ways to do that. I'm just saying, I didn't want you to think the pipe was how you would do what you just mentioned. You basically, you would read in the data set and then have a statement for the where command. So you would say, select this where this is equal to this.
Okay.
Yeah. I'll give you an example in the chat box.
All right, thank you.
Could you explain the very last line where it says true as numeric? This means it's creating as a numeric variable, right? What does that NA stands for again?
That's a missing in part. It means not applicable. So it's just like if it was in SAS, it'd be like the dot. It's a numeric missing. So for the different types of variables in R, the NA kind of looks the same, but when you're creating a variable, it can be kind of finicky. So it's really good to directly intentionally specify if it's not M or F, everything else is an as numeric missing or NA. So you'll see down here for the age cap, if it's less than 40, do this. If it's greater than or equal to 40, do this. For everything else, it's an as dot character. And
so when you have the actual data frame and if Sykes is missing, would you see an A there or would you see a dot?
you see NA.
Okay, but that NA is actually a numeric kind of NA for the processing.
Right. There don't happen to be any missings in here, but we'll see data later and you'll see it says NA in.
Got it.
How would you modify the case one for sex instead of having numeric NA? We would like to have, say, a string equals to unknown or unspecified.
Okay, for this one?
No, for the text one.
And you want it to, if it's not M or F, what do you want it to be?
Say it says unknown instead of an A.
I mean, you could have it be like 99 or something.
Oh yeah, okay, I get it. And
But,
yeah, so maybe let's jump to the second case one. So for age, if it is, otherwise, let's call it classified as unknown or something like that.
Right, so if it's a character, you have more flexibility, or you can be more descriptive. So for everything else, I could say some other age.
Oh yeah, it's a simple thing.
But if it's a numeric, you have to code it to something that just everyone knows means some other value.
And then for the age cat that you defined as a character, like how do you define the length? Do you define it ahead of time or afterwards?
You don't really specify lengths when you're programming. It just gets kind of assigned based on the maximum length. So it's more what do you call it? Variable length. So here, well, that's not what I want. If you look in like the kind of glimpse of it,
Right.
it doesn't really give a length. Let me
I guess I'm like used to be having more control over the length.
yeah, and with R, you don't really worry about it as much.
Okay.
Because like if you have a software like SAS, they're like the character variables are fixed width. So if you assign the variable sex and you give it a length of 1,000, then you're going to be wasting a lot of space.
Right.
And things are going to run them a lot more slowly. Okay, so this last variable, it's like I'm building a sentence. So I'm using what's called a paste function. That's from the base R package. And it just concatenates strings and variables together. So if it's in quotes, it's a constant string. If it's a variable, it's not. And you end up with, you can make like a nice little sentence for as a variable. So again, we're just kind of scratching the surface for creating variables. But this is kind of a topic to probably spend half a day on. But the purpose of this workshop is to expose you to it, give you some examples, maybe a little practice. And then hopefully when you go to learn the language in depth, if you don't already know it, you'll have a starting point. Okay, so for this one, there's a little exercise. And this one, it's got an operation down here that's piped together, but there's pieces of it missing that you need to fill in. So to fill it in, you can glance back here and kind of get a feeling for the syntax. And then fill it in here. Why don't we take 5 minutes and you can try to do this exercise. Again, if you finish or you're struggling with it, you can go to the solution keys folder and look in there. right, to keep things moving along, again, you always have the solution right here. So we wanted to read in dm.rds, keep these three variables. Keep only the subjects from arm A and arm C. So we have the arm equal arm A. And then an OR is a pipe. Arm equal arm C. So this is if it's arm A or arm C. Create a new variable called sex2, which is male. If sex is M, and female if sex is F. Then create a variable called about, which is a sentence of the form, my subject ID is that, and I am in treatment group this.
So when
Okay.
you're reading that RDS, at that stage, you cannot subset only on that three variables. You just have to go through like select as a next function to select them.
I'm
just
That-
curious. I mean, we don't need to spend time on it. Yeah.
yeah, I can I guess follow up with everyone on that. If there's, you're saying, is there a more efficient way to do these three?
At least the first two. So when you're reading it in that data set, is it possible just to specify these three variables in that first read RDS function?
Let me check the base function of that. I'm sure there is a way. I'll have to follow up
Yeah, no worries.
with the
Thank you.
participants.
Yeah, I'll say
But
this is pretty normal. Yeah.
This is all in memory, so it's really fast. Okay. So I guess we can move on. Again, you've got all the solution keys and original code there. There was a question about, like, later on, can I download everything to my desktop? And whatever directory you want to start with, you just check and then choose export, and it will download a zip file of everything to your download folder. And that's the same way if you wanted to move everything up into RStudio Cloud from your desktop. I could choose upload, choose the target directory, then choose a file on my desktop. If it's more than one file, it has to be a zip file, and that'll just expand once you get it, once it gets up there. So yeah, if you want to download stuff under the more, there's the export feature. Okay. The next part I want to go into is called combining data frames. When I say data frames, it could be a tibble or a data frame. They're very similar. It's just a tibble has a couple of nicer properties that I'll mention here pretty soon. It's pretty subtle. So here we're going to be combining data frames. So you could be stacking data frames that have the same variables, but just different records. Maybe you've got a demographics from two different studies. So they have mostly the same variables, and you just want to stack them up on top of each other. So as you can see here, I've got demo A, demo B. Imagine those are from 2 different studies. And I think I'm going to clean up all these things out of my environment, clean up my console. So I'm sure if I get a message that it's actually from what I'm running here. Okay, so we haven't really talked about this yet. This is where I'm just defining, right here, I'm defining a tibble and having the data embedded right in it. So it's just like, if you're familiar with SAS, it's like a data step with a card statement. It's just a handy way to, if you want to do some little examples, you can just have the data right here. So when I run this, it's going to input patient, sex, and age. And if I have it as a number, it's a number. If it's a character, it's a character. So here I've got demo A and demo B, and I intentionally have slightly different variables. So the study B demographics has the variable smoker, but it doesn't have the variable age. And study A, the demographic has age, but it doesn't have smoker. Just like any language, if you're going to be stacking data tables, you want patient, the variables with the same name to be the same storage type. So numeric to numeric or character to character. Okay, so if I look at these 2 tables, let's say I want to stack them together. What I would do is just use a function called bind rows. And that's from dplyr. There's a bind rows and a bind columns. But for what we're doing right now, I just want to use the bind rows. And if I run this, even though I have slightly different variables in them, it works because the common variables have the same type, numeric or character. So I think earlier someone asked, like, how do missings show up in here? You can see it shows up as an NA, looks the same whether it's a character variable or a numeric. But I've got a nice little data frame or tibble with these records from study A and these records from study B. So that's stacking data frames. What if I wanted to merge or join data frames? Let's imagine we have a nice little data frame for adverse events for study A and study B. And also notice I've got subjects 1, 2, and 3 in study A in the demo, and 1 and 4 in the adverse events. So patients 2 and 3 are not in study A for AE, and patient 4 is not in demographics. So this will help us with the different types of joins we're doing. So let's read in these little AE tables. Great. And let's say we want to stack the AE tables together. We can just run that. And these 2 had the same variables, so there's no NAs showing up, no sparse data. So I've got patient, visit, and AE. So this is naturally adverse events. You've got multiple records per patient. And in demographics, I've got 1 record per patient. That's how it usually goes. So if I want to join these together, I'm not going to really have any Cartesian product problems where it's a many-to-many join. Okay, so base R, there's a merge function, but I like these tidyverse functions better. And these come from dplyr, which is one of the packages in the tidyverse. So they have kind of a nicely named set of functions: inner join, left join, right join, and full join. And you're all probably familiar with these different types of joins if you've programmed in other languages. Essentially, these are pretty simple. I'm going to take the AE both and join with the demo underscore both. So if I do an inner join and I specify my join variables or my key variables, I'm going to join by patient. So I get a nice data set, and it only keeps the patients that are in both. So that's pretty straightforward. If you have more complicated joins, then there are more options. But we're going to keep it simple, and this gives you a good grounding if you need to do two joins. So left join, only keep the data if the patient is in the left data set or the demo data set. And here we've got more patients because there's a little more, the joins defined a little more loosely because it's left join. Any patient that's in demo gets included even if they're not in AE. So there's a little sparseness of data here. And there's a right join, but people usually don't use a right join because they just flip these around and do a left join. But just for completeness, there's a right join, and it's going to only keep patients if they appear in the AE data set. All right, so it's just 1 and 4, 11 and 14. Those are the only ones that were in the AE data frame. Then there's a full join. And the full join is just what it sounds like. People come in and stay regardless of which data frame they're in.
Quick question: what if visit is character in one data frame and numeric in another?
You mean what if patient is?
No. What if the visit is
Okay,
in
so
one set and the numeric in the other bit?
okay, so you're asking, like, what if the same variable name is in two different data frames that you're joining and it's not part of the join condition? Is that right?
If it's different type.
Okay.
There are two data sets that you're joining. One has visit as a character, the other has visit as a numeric. What happens?
That's going to be okay as long as it's not one of the join variables. So I'll just demonstrate that real quick. Okay, so demo A and AEA both have visit, and they're of different types. I forgot a comma up here. All right, so visit is numeric in AEA, and it's character in demo A. Let's just do a little test join here. Okay. So there's two types of variables you have to worry about when you're joining. The ones that you're joining on, or think of them as the by variables, then all the other variables. If two variables have the same name, but they're not, and they're not one of these, then R makes a .x and a .y variable. So that's why it can handle having the same variable of two different types, as long as it's not the variable you're joining by. Does that make sense?
Yes. What if the joining variable is different type on different data set?
I think you get an error.
Okay, thank you.
And in the interest of time, maybe that's something we can individually play with. You've got this program and you can change these variables. Now these can have two different names. If the demo data set had Pat and the AE had patient, then this would be how you do it. I don't think they can be two different types.
Thank you.
And just for fun, I want to show you kind of a weird join. R has a lot of different object types. So I want to show you this join. I don't know when you'd use it, but this is called a nest join. Not sure I'm getting an error. Oh, I forgot to by equal. All right. So if I join these two using a nest join, look at this. So I've got one record per patient, but every value in this variable is another data frame. So usually if I learn something new, like within a few months, I'll figure out a place to use it. So I challenge all of you to find a place to use a nest join. All right. And there's a couple other joins. I forgot to include in semi-join and anti-join. Those are, they're called filtering joins. And they just kind of keep things that are either in common or not in common between the two. I can just show you here. So semi-join, it filters the first data set and it only keeps the patients that are in the second data set. So I only have the demo variables. And it only keeps the records if the patients appear in the second data set or the AE data set. And then there's also one called an anti-join. And that only keeps the records for the patients that do not appear in the second data set. And these are called filtering joins. I guess just keep these in your back pocket and remember that these exist because they can be handy. It's like a proc SQL intersect or proc SQL accept, kind of similar to those. All right, so let's move into, you can try and do the exercises. And again, these are more fill in the blanks. So I've just got 2 of these STDM data sets, just a few variables in each. And then you can fill in these, the inner join and the left join, just a short exercise.
So one question, if you don't know, like there's so many packages, right? And there's so many functions. If you don't know the functions or, you know, I mean, if you're, you know, looking to do something and you don't know which function it is there any easy way to find it?
Well, so for instance, let's say I wanted to find out all the, one way is to go look in CRAN. And out in CRAN, there's usually a reference manual. And this reference manual will have all these functions in here and some documentation.
Okay. So you at least have to know about the package at the minimum.
Yeah, and you could go, I think there's, I'm sure, a number of books by Hadley Wickham, who wrote the Tidyverse. So he'd have, can't remember the name of the book, but there's probably like a Tidyverse Bible that he has.
Yeah.
That you could read.
R for data science. I can put that in the chat box for people.
Oh, yeah, thanks.
Yeah.
Thank you.
And there are also ways, if you put it on the package name in this library function, then there's documentation in here with links to good documentation. So here he's actually the one that maintains Tidyverse. So anything he writes is going to be good.
So it feels like learning R is just R base, and then like you'll have to learn these packages, right? The syntax or the function within the packages.
Yeah, so I think it's good to learn some of the base first, and then move into Tidyverse, because if you really looked in the code behind these functions, most of the functions in Tidyverse actually are built on a base R function. So if you looked at inner underscore join, most likely that is building off of or calling the merge function from base R, which kind of has similar syntax, but the tidyverse was built to make programming easier by having the function names more easy to interpret and having the arguments within the functions more easy to use. So it's kind of got names that go together and make more sense.
So for clinical trial work, day-to-day work from, let's say where I convert raw data from CRF into SDTM into Atom, so would tidyverse be sufficient to handle that?
It should be. You've really got to go by what your organization wants you to use. Every company is going to be a little different. So company A might say, only use base R. We're not going to have any other packages.
Okay.
Company B might say, we're going to use base R in the tidyverse. And it all comes down to what they want to maintain and validate, because you've got to, if you're going to be using this for submission work or in a regulated environment, you can't just use any package you want and then get a surprise when a function doesn't work like it's supposed to, or something like that.
There'll be a couple of talks at the conference about this topic, but typically most pharmaceutical companies have a internal repository of packages that they maintain, and they go through kind of a vetting process to say, hey, these are the packages and the versions that we're going to maintain for clinical trials work. Usually that's around 200 to 300 or so packages. Obviously that's the base packages, and then typically some tidyverse, and then there's also a new set of packages called the Pharmaverse, which are packages that the pharmaceutical companies are starting to put out. So for example, there's a popular one there called Admiral. And so for getting Atom and STDM data sets, you may choose to use Admiral, which is a Roche package, for example. So.
So what do you mean by maintaining those packages? I think it's going to be whoever is publishing those will be taking care of that part, right? I mean, is there anything Sponsor would be doing apart from just downloading them? Yeah, that's a great question. So typically for clinical trial, especially at some of the bigger companies, they have what's called an internal repository of packages. And so basically they have a small server in-house within their intranet where they say, hey, anybody that's going to do clinical trials work here, when you install the packages, you're not going to install the packages from CRAN. And so what you're going to do is rather, our IT department is going to get all the packages from CRAN that we approve, and we're going to put those in-house. And then when you run install.packages inside of our studio, rather than going out to CRAN, likely your IT team will set it up so that you install package from your internal repository of packages. Now, some companies may not do that. But what they'll do is say, hey, we're going to do this on a desktop, but on your Windows machine, and you're still going to install from this either repository packages, or here's the list of approved versioned packages that we want you to use. So there's a couple different ways of going about it, but most of the bigger pharmaceutical companies that you'll see have talks at RN Pharma, they usually have a maintained internal repository of packages. And I'll put some links to some articles about that. Thank you. That'll be great.
Yeah.
Okay. So hopefully you all made gains on that exercise. I see my exercises must have overwrote my solutions here. So if I want to do an inner join for these two, of course I'd have my my two data frames here. And then my join variables. And let's see. Looks like I want to join by U subj ID. So I am going to. I like to always kind of completely specify this. If you just left the by off, I think R would look for common variables to join by and just do it, but you run some risk there. All right, so this is a, we haven't really talked about this R object. It wants a vector here. And like, if there were more than one variable to join by, then I would have a comma and more variables to match by. All right. So if I run these, that works there. And so these functions are nice. I can actually use the same arguments. It's just a different function I'm using. And you'll notice that RStudio kind of tells you if you're making a mistake. See the little red X over here? And then also, if you're just to the right of a parenthesis, it highlights the other parenthesis it's matching up on. So it's kind of nice to kind of notice that. It helps you in your programming. Helps your troubleshooting. All right, so we just did an inner join and left join there. And hopefully everyone felt comfortable with that. All right, let's move along. I don't know if anyone needs a break or you've just been taking breaks during the exercises. If someone really needs, if a group of you need a break, we can take a couple minutes here.
Yeah, maybe 5-minute break.
Okay, 5-minute break,
Okay.
everyone.
Thanks.
I have a simple question. I was just thinking earlier when you were showing the pipe for the McGritter package, related to the McGritter, I noticed that you didn't have to load that package specifically. Is that because it's part of like one of the other packages you loaded?
Yeah, it's actually part of the tidyverse.
Okay, so it is part of Tidyverse.
Yeah, pretty sure.
Yeah, there's a little bit of history there that I'll just briefly mention is that the MagRitter package predated the Tidyverse. I believe it came out around 2015, 2016, but it was a critical way that people worked with the piping and the workflow of the code, and especially for dplyr and tidyr. So the MagRitter package was incorporated into the Tidyverse as a dependency. And so when you load the Tidyverse, it brings in that pipe operator from MagRitter. Because the pipe operator and the MagRitter was so impactful and really revolutionary in the way that it changed the readability of the code, the base R language now has its own native pipe. And so there's actually two pipes now. There's the MagRitter pipe and then the base R native pipe. You have people in both camps that still choose to use MagRitter. Some people are now using the base pipe. Just some interesting history, I guess I thought I'd throw in. So.
Yeah. What version do you have to be on to use the new base R pipe?
Yeah, that's a good question. It probably came out in the last 3 or 4 months, so probably a pretty recent one. And so you will see, I'll put a link to it in the chat box. Sometimes people will use the native pipe. I'm still very much MagRitter because I'm just used to it. But yeah, probably a newer version of R, I suspect. But you're on 4.2.1 here, so that's probably safe, I would say.
Yeah, was it like the pipe greater than sign or something?
Yeah, I honestly don't even know what it is. I'm Googling it, our native pipe. Yeah. So I'll put it in the chat box. Yep, I can't quite remember off the top of my head.
Thanks.
Yep.
I don't think I'll use it because I'm so used to the, the MagRitter, but.
Right, me too. You too.
I would caution using it, just because if someone has to run your program and it's an older version of R, it so it looks like the pipe greater than will also work. But if like you were developing on your desktop using 4.2.1 or something, and then you saved it to a project and it runs in your lockdown environment that's on, I don't know, 4.1.3 or 4.05, it may not work. So I might wait a while before I started depending on it. And fun fact is Control-Shift-M will just create that little pipe.
Oh, I like that.
If if you're really
Okay.
into shortcuts, the keyboard shortcuts here, Alt-Shift, there's a whole bunch
Oh,
of them.
wow. Yeah.
Now, most all of these work in RStudio Cloud or the desktop, but there are one or two that Chrome kind of messes with a little bit. But if you're into shortcuts, here's a list of all the shortcuts off the help menu. I'm not a big shortcut user, but they're handy for something you're doing quite a bit. All right, so let's get started.
Yes, there's a number of operators available in R. We probably should have some kind of a class on it in the future. Because
Yeah, that's a good idea.
Yeah, there's new ones coming out too, just recently for Quarto, right? So
Yeah, exactly.
Hard to keep up.
I will definitely say that one of the interesting things is the data science and the R ecosystem, it changes and evolves pretty quickly. For pharmaceutical clinical trials programming, what the companies tend to do is tend to lock things down a little bit. So there's more of a 6-month or so lockdown, maybe even longer for some of the pharma. So it's kind of two different worlds, the quickly evolving data science space and then the pharma locked us down space, especially for clinical trials. So balancing both of those is an important topic. And so we're going to have a workshop next week on managing environments with for the admins. So Ed, who just commented, will be on that as well. So if you're sitting there on the admin side or interested in the admin side, you might attend that for some of that conversation. So.
Yeah.
Yep.
All right. So what we're going to do now is start the 04 program group by processing class code. So I'm in the workshop code, class code, program 4. So group by processing is just what you think it sounds like. It's working with variables that are grouped by or in groups based on variables. So if I look in, I read in tm.rds, and I'm going to keep subject ID, arm, and age. You know what? I'm going to clean this up. Start with a clean slate. And when I clean these, it doesn't clean all the packages up, so they're still loaded. But if I did a restart R, I might have to reload my package. All right, so I've got my DM and subject ID, arm, and age, just like I'd expect. So you might be tempted to do something with using arm as a by group. So usually what you do is you can sort the data, and you can see if I sort it, it's in the groups by arm. So all the subjects in arm A and B, C, and D. And then the screen failure. So then the age I also sorted by, because maybe I'd be interested in, oops, sorry. maybe I'd be interested in picking off the first record for a by group or the last record for a by group. So if I did that, I'd want to group by the variable I want to use. Like, let's say if I were in talking in SAS terms, it might be if first.arm. Then I'd pick off the first record of the by groups that are defined by sorting by arm. So when I do this, notice there's an attribute on the tibble or data frame or tibble, I guess tibble. Oh yeah, it says right here, tibble. And it's got a group attribute on it. And it's grouped by arm, so it's just like we'd expect. And then it even shows which rows are in each of the by groups. So it's kind of interesting what's here in this little glimpse. So if I wanted to mimic like picking off the first or last record of a by group, I could use this function, slice underscore head, which picks off the first record for each by group. There's a corresponding one called slice underscore tail that would take the last one. So if I ran this, notice DFMD only has 5 records because I picked off the first record for each of these by groups. And notice there's a nice little parameter here. What if I wanted the first 3 records? It would give me back the first 3 for each by group. Screen failure only had 2, so it just grabbed those 2. If I wanted to do the last 2 of each by group, I could do slice underscore tail and just say I want 2. Then it would give me the last 2 for each of these by groups. So this is kind of a nice way to mimic the first dot and last dot, if you're familiar with SAS at all. Okay, so I could do this all in one step if I wanted to, but I just wanted to talk through it in steps. So I could throw a pipe on here and do these 2 and throw a pipe on and do this. That would probably be how I do it if this was what I was doing. But just for example, I split it into 3 steps. Okay, so the group attribute can be used with other functions. But this one is just a quick little lesson on how to create the group by tag in here and how to use it to pick off the first or last records of a by group. But we're gonna, in future lessons here, we're gonna be looking at doing that. So the exercise for this, which we have all strung together in one process with the pipe, is open the exercise. So I'm in workshop code exercises, the 04 program. And there are some instructions here. So you just need to fill in these functions based on what's asked. And remember, you can glance back at this one. So go ahead and have some fun.
So arrange is more like a short function, right?
What function?
So arrange is more like a shorting, right? It's just like a short function in SAS. It's
Short?
arrange. Yeah, when you're shorting, not the SHORT, but SORT, like short, when you're shorting it by different variables.
I'm not familiar with that function, but this is just like if you're in a data step and you want to do first dot, if first dot, or if last dot. It's kind of similar to that.
But this, what is arrange is doing? Arrange is just arranging it by the sequential.
Oh, I'm so sorry. I know what you're saying now. Arrange is just like a sort. Yeah.
Yeah. Okay.
I thought you were saying short, but you were saying sort. I was
Yeah.
being a little dense. It's getting late on a Friday here.
Thank you.
Mhm.
Brian, quick question. Does the group by function not automatically sort the variables that we define in the group by?
It does not change the order of the data. It just applies a tag that tells what the data is grouped by. In fact, if you didn't sort it, you have the chance of, if you were trying to get like the lowest age, if you're doing a first dot type operation, you run the risk of not getting the lowest age, just whatever one is on top.
I see. Okay. Thank you.
Okay. All right, you should be looking for something similar to this. So this one's a little different. It's got multiple variables in the group by. So it has arm and sex in the group by, slice tail n equals 1. So this is like, it would say if last dot sex. All right. So let's keep moving. Love to get through all these before 4. And let me just tidy up the environment here a little bit. All right, next we're going to talk about summarizing data. And so we're going to be looking at a function called summarize. Now this is different than, we're going to read in a vital signs.rds file from SDTM and join it with demographics. And then just keep these 4 variables. So you might be wondering, well, I'm calling the inner join, but I only have the DM in this inner join function. That's because when I have a function that's the next operation in a pipe, there's a good chance that that function will just take what's being passed to it as the first argument. Now there's a few functions out there in some of the packages that this doesn't work on and you have to specify it, but this one is assuming the first parameter is what's being passed in here. So I don't have to specify the first parameter here. So that'll take a little bit to process and get used to, but this is how it is. So when I run this, it's reading in DX. It's doing an inner join for the DM and then selecting those 4 variables.
So ideally, there is no need to do read RS, right? You can just do the inner join and that should do it.
No need to do what?
The very first line, read RDS, because you're just basically joining those 2 data sets, right? The vitals and the DM.
Right. I could have done the inner join first with both data frames in it. That would actually probably be more efficient. So you're right.
Okay.
So I think I like your idea. So I'm going to comment out that line. So it's a pet peeve of mine when code gets really wide, I can't see all of it. So I'm just wrapping it around here. Could even go more extreme. So right, the person commented that I wouldn't even need to do the separate RDS. I could just start out with the inner join and go on from there. That's a capital idea. All right, so I've done the inner join and summarize. There's a function called summarize, and it can be spelled with an S or a Z. So you might run into a program where it's spelled like this. I don't know, maybe that's a British spelling, or the Z is more American spelling. But anyway, we're going to be using a summarize function, and you almost think of it as a proc summary if you have a SAS background. And I'm grouping by these variables. Okay. I think I opened up the solution accidentally first. So that was supposed to be your exercise. I gave you the solution here. So apologize about that. So to reiterate, I'm in workshop code, class code 05, summarizing data. Okay. Let's start over here. So I'm reading in the DM data frame, only keeping 4 variables. Then I'm using the summarize. So if I read this in, when I summarize this, who can tell me, or just someone can say out loud, how many records do you think are going to be in this resulting data frame?
One.
Correct. Because I'm not grouping by anything. So when I run this, I'm going to end up with a data set with 1 record and a variable for each of the statistics I asked for. Notice these functions if there was a missing in there, the missing would propagate. So this option tells it to just remove any missings from the end calculation. So this is a way to get the number of non-missings. And this is a way to get the number of missings. So exclamation means not. Is that NA means is it missing or is it an NA? So this is the number of non-missings, or N, and this is the number of missings. Then the rest of these are pretty self-explanatory. These are interesting. You can request certain, the first one or whatever one you specify. The last one. So this is not to be confused, but it's similar to a function called summary. So it gives you a real kind of high level summary of each variable separately. So this is summary. But what we're talking about is summarize. So this gives me back 1 record because I'm not grouping by anything. So let's say I want to get that set of statistics for each arm value. So I just arrange and group by. Now, if I'm not picking off, like using slice, I might not need this arrange, but I always, if I'm grouping by a variable, I arrange it first, just because it makes me feel better. Because I don't want any funny business. So when I'm grabbing first stage, I'm sure it's maybe what I want. And here is my nice set of statistics. Arm was my group by, so I get them for each value of this. And if I want to do it by 2 variables, I just have multiple variables in the arrange and a group by. All right, so this is a nice way to get kind of a summary of your continuous summary statistics. All right. In the interest of time, we already looked at this. I had was going to have you join together a couple and then group by ARM and VS test. Just kind of a vital signs. So you can try this exercise after the workshop at some point. Whenever it's 5 o'clock in your area, you can have a beverage and try these exercises we didn't get to. But in the interest of time, excuse me. So this is grouped by ARM and VS test. So here I'm getting a nice set of statistics based on what arm or treatment arm they're in and what vital signs test it is. So height is only collected at screen. So there's a lot fewer of these. Height and weight. So, but this is a nice way to get summary statistics out on your continuous variables.
I had a quick question on the first and nth that you're doing here.
Mm-hmm.
Are they sorted in any way, or are they just picking up the first result or first VSS or VS or RES in the data?
So in this case, I'm sorting them.
But that's by ARM and VS test.
Right, so I'm getting like the ninth smallest.
If you look at the result, when you say first underscore VS or RES, I would expect that it'll be the minimum value or something close to it. So if you look at the first row, minimum is 50. Do you have to also sort in the arrange, add VS or RES if that's something you want?
That's a good catch, and I think you are right.
All right.
Thanks for bringing that up. I forgot to sort here by this. So everyone cross your fingers. Yes, by 2. Yep, so the first is 50 and the min is 50 now. And the max is 98. And the last is 98. So yeah, I failed to sort by this. So I'm virtually tossing you a candy bar. Did you get it?
Yep.
All right. So yeah,
so if you don't sort it, it's just whatever was in the data in that first place. And
yeah, you're exactly right. So the sorting when you're doing the group by is important to consider, especially if you're picking off first or last or a certain number of it. All right. Our next topic is pivoting. A lot of people call this transposing. So it's taking your data, and I consider this wide because there's a record for every visit. So week 2, week 4, week 8 would be very wide. Versus a vertical format where regardless of how many visits there are, they're all encapsulated in this column. So it's useful to be able to switch between the horizontal and the vertical format. And in R, we call that pivoting. So if we start out with horizontal and want to go to vertical, the function is called pivot longer because we're making a longer data frame, more records, fewer variables. And we're also going to briefly mention comparing data frames. So let's read in these little data frame tables, and let's look at the pivot longer. So you can pretty much envision, if you have a familiarity with SAS, the different things you have to specify in a proc transpose. So horizontal to vertical, specify the columns that we're transposing, baseline and week. And we're going to throw those into one variable called visit. And the values of these will go into lab value. So essentially, when we verticalize this or pivot longer, it's going to look exactly like this one. In fact, we might want to compare those. So how do you compare two tables or two data frames? There's a few different ways. There's just saying this one equal this one. So what do you get out of that? It goes through and shows true for everything that's the same. So this is one way. It's just comparing all the values in. There's also a function called identical. So the identical function just says, is this tibble identical to this tibble? And that's kind of a one-word answer, true or false. So the first one, you get a result back for every value. And this next one, you get a result back. Either they're both identical or they're not identical. Then there's a package called diffdf. And that has a function available called diffdf. And you can think of it kind of like a proc compare. And if there's no problems, you just get a nice brief message back. If there are differences in variable attributes or values in the variables, you get a lot more back. So for instance, if I compared lab data H to lab data V, then diffdf is going to have a lot to tell me probably. So that there's a lot of things that aren't the same in here. So I get a whole bunch of information about what's different. So these functions are handy, like if you're building STTM or ATOM data sets, when you're done, you probably have a QC data set to compare it to. So these are handy to have in your back pocket so you can do that comparison programmatically. Okay, so let's say we wanted to take the vertical data set and make it horizontal. So we're taking lab data V, which has lab code, visit, and lab value. And we want to flip up these variables, these values of visit, to be their own variable. So we're going to pivot wider. So we come out with lab H2, get the nice little data frame just like I had in the beginning. And I can run all my checks and see that the horizontal data set I made using pivot wider is identical to the original one that I had up here. So life is good. Okay. So I think we have a few minutes. You can try and do the exercise if you'd like. The solution is sitting there as well. Pivoting. So what we have is some vital signs data here. And we are asking you to take this vertical and make it wider, make it a horizontal data frame. You just have to fill in the missing arguments here. And then whatever comes out of this, take it and make it vertical. So you just have to fill in these values here. And then we can compare them at the end using the diff-df function. So why don't you play around with that for 5 minutes?
So with this df function, is there any option to specify to compare by specific variables, or is it just compares data frame with another data frame and automatically picks up?
Are you saying like if you want to compare it by ID or something?
Yeah, exactly. Like, is there any way to do it? Oh, keys, okay.
Looks like keys is the option.
And you have to, I'm guessing you probably will have to like arrange it as well, like both the frames.
I think it would take care of it for you.
Okay.
I've never really used the keys option before, but it's there. And I think the diff-df function takes care of the sorting in the background.
Okay.
So I'm sure it's doing some kind of special join or whatever it does. It takes care of the arranging or sorting. All right. So I know I didn't give you much time, but you can play around with it later. Want to fit in a few more things. So what you should have come up with is something similar to this. So end up with a VS data set. Subject, visit, and pulse. And we want to make that horizontal. So this makes it wider and shorter. And then take the vertical one, or take the horizontal one and pivot longer to put it back the way it was. So we end up with VS vertical. And then why don't we do a diff-df and no issues are found. You might be looking at this option we didn't cover in our example. Drop the NA values. So let's say I had that true. Remember, it included this NA in here. So let's say I have that as true, it won't include it. So do I want to drop it as true so it's not there? So now if I compare, I get a message, there are rows and base that are not in compare. So I might use like an anti-join or something to flush out the difference. And I think there are also some more options where I can get more details out of this. But so anyway, that's kind of pivoting and included comparing data frames or tables at the same time. All right, let's clean up a little here. All right, so duplicate data. I'm going to include an additional package in here called the janitor package. The janitor package has some nice functions in it that helps you clean up data and identify duplicate data. Here's one of these tables I define using the tribble function. So kind of like a data set with a card statement. And I've even got some dates in here. We didn't talk about dates yet. It's kind of hard to include all the information we need to in this. But dates are stored as integers in the background. And it's just the number of days since January 1st, 1970. So you see here screen date. Screen date has it's a type of date. So it's kind of handled kind of as a date. You can do arithmetic with it. And there's all kinds of functions for dates and times and date times. But that's outside of what we could fit in today. Probably gonna be a good topic for another workshop. But in any case, notice in this demographic data, we have a no-no. We have someone with the same investigator and same subject number. So usually you don't want that in demographic data. So how do we identify that? Well, in the janitor package, there's a get dupes, and it will kick out, depending on what keys I specify, it will return the duplicates. Maybe I didn't run this. I might not have loaded this. All right. So in demo underscore dupes, I've got these two records because patient and visit had a duplicate. This doesn't really say what I was looking for. I was really, when I started talking, I was saying investigator and patient. So that's what I should have in here. So it kicks out records where these key values are repeated. So this is kind of a handy function to use. There's also a couple different functions in the janitor which will help you clean up data. For instance, you can remove an empty row, empty columns, or even rows and columns at the same time. So notice this first one, remove empty row, so it removed the empty row. The second one, remove the empty column, it took off that. This one says remove all the empty rows and columns, and it gets rid of all of them. So you may never use this, but it's just nice to know that it's there. There's also one for removing a constant column. And if you wanted to ignore missings on the constant, so at first it didn't get rid of A because there was a ones and a missing. But if I say NARM, NARM equals true, then it gets rid of the constant column disregarding the missings. All right. The other nice thing in the janitor package is it has a function called round half up. So for example, if you have the value 10.5, R doesn't round the same way as you learned in school. If you want it to round the way that you learned in school, you have to use the round half up. So when we learn in school to round, if it's 0.5, that means make this 11. But in R, it follows some kind of standard for rounding. It rounds to the nearest even. So that's something to be aware of when you're using the round function. But in janitor, there's a function round half up. And there's also a function compare DF cols, which will compare two data frames, compare the columns in them. So we've got two data frames, data demo and data demo alt. And it'll make a nice little comparison. Column name, DOB. It was in data demo, but not data demo alt. I and V was numeric in one and character in the other. So it's a nice little function to compare the columns between two data frames or tables. So this is kind of just kind of highlighting some useful things in the janitor package for data quality type stuff, comparing, finding duplicates, things like that. So we don't really have any time for exercises, but I do want to get to the next topic just to show you other things that are nice in the janitor package.
Janitor is not part of Tidyverse, it's a separate package?
It's a separate package.
Okay.
So the janitor has a nice function called table, spelled with a YL on the end. And it kicks out kind of nice little reports of ends and percents. So this is just race showing n percent. Shoot, I can't remember what this is, but you can do it by 2 variables. And then there's a whole bunch of syntax. Oh, there's 3 variables too. Then there are these functions called the adorn functions, which you can turn out making kind of nice little tables. I think I forgot to build this. So here I'm adorning totals on a row total and a column total. And then here I'm also adorning percentages on, defining the denominator, and doing some percentage formatting as well. So I'm kind of ending up with a nice little table here. So notice I'm not assigning this to anything. I'm just putting the table straight, piping it right into these. But I could assign it. And then have it saved out as a data frame or a tibble. All right. So there's a whole bunch of examples in here you can run through just to see some of the nice tables you can end up with. Here's one, adorn the ends in after the percentage. So you get the little count after the percentage. That's kind of nice to be able to do that. All right. Then towards the end, we haven't talked about factors at all, but there is a function you can put on a variable. I guess you can liken it to a SAS format, but it's not the same. So for example, if we look at data underscore demo, notice got this variable sex here, M or F. But let's say we want to control the order and the labels. And maybe there's even a value that doesn't exist in the data. Maybe on the case report form, there's also a did not answer. So maybe that's a valid thing to have in our kind of counts and percentages. I can make a new variable that's based on sex, but define it as a factor. And then do my janitor table and adorn statement. Okay, so I called this, I defined it as all together. So let's go over here. So I've got a nice little table, and in addition to male and female, I've also got did not answer. Even though they're all zeros, it included it in because that factor defined that as if it had kind of like a format on it. Okay. We're down to the last 10 minutes. All this code is out there, so you can kind of rerun this and play with these janitor functions, create these nice little tables. I guess one last thing I'll show you is So we've been saving all this output to like data frames or spitting it out in the console. But what if you wanted to put it out to HTML or PDF or RTF? There's a number of different packages out there to do that. There's Pharma RTF. There's some new ones in the Pharmaverse that are getting defined. R tables and Plier. There's a whole bunch of different packages for working with TLFs. I guess the one I'm going to show you is called Reporter. It's the one I know how to work with the best. So let's say I have all this from the last code, the all together. Let's say I want to take this and put it out to a nice little report. Okay, so there's a package called Reporter, just the word spelled out. And all the documentation's out here. But the way you do it is you take something that you've built into like a data frame, and you use a create table function, a create report function, and then a write report function. And these three things together will define the report and then write it out based on what you want to write it out to. So in this case, I'm choosing to write it out as an RTF. So if I look out in my working directory, which is in workshop data, see I have demo012.rtf. So if I click on this RTF, it downloads it for me to my desktop. And notice I have a nice little table here. I defined a footer and a footnote, the page 1 of 1, and I got something in the title and the table titles and a header. So you've got a lot of flexibility and power to put that out there. Where did I go here? All right. And if I wanted to write it out, say in PDF, I just change it to PDF. And I get this nice little PDF. If it goes on to multiple pages, it just takes care of it, paginates and everything. Also, I could do HTML if I want. So if you're interested in this, I suggest kind of digging in and learning about all these functions and options for these create report, create table, and write report. You can do figures in here along with other output.
So Brian, very quick question. So in terms of this, like, is there a concept like a macro in R, like what you have in SAS?
So macros, we'll just close it out with this question. In SAS, macros, as you guys probably know, it's text substitution just before compile time.
Right.
So it's a big replacement type operation. So just before compile time, like amp or whatever is replaced with a value, and then the code is compiled and executed. In R, it's a lower level language. It does not do that. If you want to mimic writing modular code that can be called over and over again with parameters, you'll need to learn how to write functions, which is probably another good workshop that could just be its own 3 or 4 hour workshop.
Okay.
So in R, it's more functions, where in SAS, people usually use macros.
Yeah, because I was thinking like if you would have to create like this type of report, and if it's 100 report, do we have to do them individually?
Right, you'd probably put some of this stuff into a function and pass parameters in.
Okay. Thank you.
You're welcome. That's all we really have time for. I'm not gonna ramble on past 4. I'm sure we've all got stuff to get back to. So just remember again, all this code is here in this workshop folder. If you want to download it to your desktop, you just choose more and export it down, and you'll end up with workshop.zip in your download folder on your laptop or desktop. We've got a couple minutes left. Are there any like burning questions anyone has? We covered a lot of material at kind of a 5,000 foot level, but hopefully all the stuff that interests you in here, it gives you a basis where you can dig into it further and use it in your day-to-day programming.
You can go ahead and end it, Brian, unless there's some questions from the people on the bridge.
Is it okay to reach out to Instructor after this meeting, after this presentation, or?
Sure.
Yeah, Brian, I think you had your contact on a PowerPoint slide. If you want to, if you have that available, you can pop that up.
Yeah, I'll just put it here.
Yep, and I just put the resources. The Credly certificate I put in the Zoom chat is just an example. There'll be a different one for this session. And